let's look at inverting a 3 by 3 matrix. So the steps are to first find the determinant, then the minors, then the cofactors, then the transpose, and then to use the formula for the inverse. The example says find the inverse of M given by this matrix. First step is to find the determinant, and so we can use any row, any column to do that for this matrix. And using rows or columns that have zeros will allow us to reduce the amount of working we do. So we're going to use the last column in this matrix to find its determinant. Now, using the law of alternating signs, we're going to start with the top right entry to find the determinant of M. And so the top right entry is 1. If we times it by positive 1, we just end up with 1. And now we times this by the 2 by 2 matrix that remains, and we cross out the row and column that the top right entry is in. So the 2 by 2 matrix that would remain would have entries 4, -3, -3, and 3. We would then have to work out the determinant of this matrix. For the second entry in the last column, we have 0, and multiplying this by -1 will give us -0 times the determinant of the 2 by 2 matrix that remains, which has entries 2, -1, -3, and 3, after crossing out the row and column that 0 is in. For the last entry in the last column, we have 1, and we're going to multiply this by +1, which gives us +1 times the determinant of the 2 by 2 matrix that remains when we cross out the row and column for that entry. Matrix will have entries 2, -1, 4, and -3. Now, to simplify this, we have 1 times the determinant of this matrix, and so to work that out, we would do 4 times 3, which would give us 12, minus -3 times -3, which is 9. And then we have -0 times the determinant of this matrix, which would just be 0, so we can ignore this. And then we have +1 times the determinant of this matrix, which would be 2 times -3, which is -6, minus 4 times -1, which is -4. And so if we simplify this, we get 1 times 12 take away 9, which is 3, and 3 times 1, which is 3. And then we have plus 1 times -6 minus -4 is -6 plus 4, which is -2. And so 3 plus -2 gives us 1. If the determinant of the matrix M was equal to 0, then it would be singular, and so it wouldn't have an inverse. But since the determinant is not equal to 0 and it's equal to 1, then we know that this matrix is non-singular, and therefore it must have an inverse. Moving on to the next step, we're going to find the matrix of minors, which we'll call capital A. Now, to find the matrix of minors of the matrix M, we look at each entry and we cross out the corresponding row and column that that entry is in, and then find the determinant of the remaining 2 by 2 matrix. And we do this for all entries in the matrix M. Now, starting with the top left entry, which is 2, if we crossed out the row and column, we would be left with the 2 by 2 matrix that has entries -3, 0, 3, and 1. And if we find this determinant, we would have -3 times 1, which is -3, and then -3 times 0, which is 0. So -3 take away 0 would just give us -3. Moving on to the second entry in the first row, the matrix that would remain after crossing out the row and column would have entries 4, 0, -3, and 1. And if we find the determinant here, we would have 4 times 1, which is 4, minus -3 times 0, which is 0. So we end up with 4. The top right entry in the first row, again crossing out the row and column, we would be left with the matrix 4, -3, -3, and 3. If we find the determinant of this matrix, we would have 4 times 3, which is 12, minus -3 times -3, which is 9, and so 12 take away 9 gives us 3. Moving on to the first entry in the second row, we would have the matrix remaining as -1, 1, 3, and 1, and if we find the determinant, we would have -1 times 1, which is -1, -3 times 1, which is -3, and so -1 -3 gives us -4. For the second entry in the second row, the matrix remaining would be 2, 1, -3, and 1, and so the determinant of this would be 2 times 1, which is 2, minus -3 times 1, which is +3, so 2 plus 3 gives us 5. Last entry in the second row is 0, so the matrix remaining would be 2 -1 -3, 3, and finding the determinant would give us 2 times 3, which is 6, minus -3 times -1, which is 3, so 6 minus 3 gives us 3. First entry in the last row, the matrix remaining would be -1, 1, -3, and 0, and so the determinant would be -1 times 0, which is 0, minus -3 times 1, which is -3, and then 0 minus -3 gives us +3. Now, the second entry in the last row, the matrix remaining would be 2, 1, 4, 0, and the determinant would be 2 times 0, which is 0, minus 4 times 1, which is 4, and so we get 0 minus 4, which is equal to -4. We have the third entry in the third row, and so the matrix remaining would be 2, minus 1, 4, minus 3, and the determinant would be 2 times minus 3, which is minus 6, minus 4 times minus 1, which is minus 4, and so minus 6 minus minus 4 is minus 6 plus 4, which is equal to minus 2. Third step is to find the cofactors of the matrix of minors. So we'll call this matrix C, and the way we find the cofactors is we use the law of alternating signs and apply this to the matrix of minors here. Starting with the top left entry, we're going to times this by positive 1, which will just give us minus 3. In the second entry in the first row, we have 4. We're going to times this by negative 1, which will give us negative 4. And then the last entry in the first row is 3. We're going to times this by positive 1, which will give us 3. The first entry in the second row is minus 4. We're going to times this by negative 1, which will give us positive 4. We have the second entry in the second row, which is 5. We're going to times this by positive 1, which will give us 5. And then we have the last entry in the second row, which is 3. We're going to times this by negative 1, which will give us negative 3. Then we have the first entry in the last row, which is 3. We're going to times this by positive 1, which will give us 3. Then we have the second entry in the last row, which is minus 4. We're going to times this by negative 1, which will give us positive 4. Then we have the final entry in the last row, which is negative 2. We're going to times that by positive 1, which will give us negative 2. And this is the matrix of cofactors. Now the fourth step is to find the transpose, which we'll call T. To find the transpose, we take the matrix of cofactors and we swap each row with each column. The first row of the matrix of cofactors becomes the first column of the transpose, and the second row of the matrix of cofactors becomes the second column of the transpose. Finally, the third row of the matrix of cofactors becomes the third column of the transpose. In other words, we swap the rows into the columns for the transpose. First row for the matrix of cofactors is minus 3, minus 4, 3. This is now going to become the first column of the transpose. So we're going to have minus 3, minus 4, and 3. Now the second row of the matrix of cofactors is 4, 5, minus 3. And so the second column of the transpose is now going to be 4, 5, minus 3. Then finally, the last row of the matrix of cofactors is 3, 4, minus 2. So the last column of the transpose is going to be 3, 4, minus 2. One way to check we have worked out the correct transpose for square matrices is to see the reflection down the leading diagonal. So the 4 and the minus 4 we can see have swapped, the 3 and the 3 have swapped, the 4 and the minus 3 have swapped. Therefore we know that this is the correct transpose. Finally, for the last step, we're going to use the formula here. So we have that the inverse of M is equal to 1 over the determinant of the matrix M, which we calculated as 1, multiplied by the matrix of cofactors transpose. In other words, this matrix here that we calculated. So we have entries minus 3, 4, 3, minus 4, 5, 4, and 3, minus 3, minus 2. And so if we simplify this, we have that the inverse matrix of M is equal to, so 1 divided by 1 is 1, and 1 times this matrix will just give us the entries as they are. So minus 3, 4, 3, minus 4, 5, 4, 3, minus 3, and minus 2. And that is how you work out the inverse of a 3 by 3 matrix.